And welcome to our channel, or welcome back if you already subscribed. If not, please click like and subscribe so you can get alerts on many more videos to come. This is part one of a series of videos that will be posted on artificial intelligence, generative AI, many more within that domain. This video is focused on fine-tuning large language modules, and we'll be definitely jumping into a code walkthrough. A quick agenda: how large language modules fits into machine learning, generative artificial intelligence. We'll do a quick overview of the script that we're going to be diving into, and it's a Python code walkthrough. Now this is fine-tuning and not training on LLMs. And then we'll go into using the model as trained. So it's important to understand some of these theoretical aspects of this topic. So before we dive into fine-tuning a large language model, it is important to understand this, how LLM works. We need to look at where they sit in the broader landscape and how fine-tuning differs from training a model from scratch. Training an LLM, or as some may call it full tuning, means building a model from the ground up. This involves feeding vast amounts of raw text data, sometimes trillions of words, into a neural network architecture over weeks or months using massive computational resources. The goal is to help the model learn grammar, facts, reasoning abilities, and patterns in languages. This process is extremely expensive, both in terms of data and compute, and also dollars. Hence why big corporations are the one that does it. However, on the other hand, fine-tuning, which we'll be focusing on, starts with pre-trained models. Rather than learning language from scratch, the model already understands general patterns of human communication. Fine-tuning is about specializing that base model for a specific task or domain, like customer support, medical data, legal documents, or scientific writing, many more areas, or many more domains. By training it on a much smaller task-specific dataset in comparison to when training. Think of it like this. Training teaches a model the entire language, or full. That's why we call it full in some cases. Fine-tuning teaches it how to speak fluently in a specific context. You will hear a term when we do fine-tuning. You'll hear a term PEFT, P-E-F-T, stands for parameter efficient tuning. Use libraries like LoRA, QLoRA, adapters. This enables adaptation of large pre-trained models by only fine-tuning a small number of or extra model parameters instead of all models parameters, significantly decreasing the computational storage cost. So you will hear about some models have 7 billion, 13 billion extra parameters. Well, training is that you're going to train all 7 billion, but fine-tuning is either that you're going to introduce new parameters or you're going to train a small portion of those parameters. So that's the huge difference. Now that you have an understanding of the training versus fine-tuning, which we'll focus on, let's understand how LLM fits into machine learning and generative AI. Machine learning is a subfield of artificial intelligence. As you notice in the diagram, it's the blue area. Outside of that is AI. That this enables computers to learn from data and improve their performance on tasks without being explicitly programmed. At its core, ML involves training models on data to make prediction or decision. It is the foundation of most modern AI systems, from spam filters to recommendation engines to self driving cars. Generative AI, the green portion there, is a subset of this machine learning focused on creating new content: text, images, audio, video, code, etc. Instead of just classifying or predicting, generative models learn the structure of data so they can generate new data that looks similar. For example, writing an essay, composing music, or generating images. Now, a subset of the generative AI, which is also a member of ML and AI in general, large language model, the orange portion here, like GPT, BERT, Llama, and BERT is the BERT, and Llama, LLAMA. Look those up, get some understanding, read about them. Are specific kind of generative AI model trained on massive text data sets to understand and generate human language. They are built using a deep learning architecture called transformer, which allows them to handle long range dependencies in text. They are trained using machine learning techniques, specifically unsupervised or self supervised learning, on large corpora of text. After training, they can be fine tuned or promoted to perform or prompted to perform a wide range of tasks, such as writing code, any language, Java, Python, C, etc., answering questions, summarizing documents, and much more. Okay, so let's do a quick script overview before we dive into the script. The script involves a comprehensive pipeline for fine-tuning large language models using Hugging Face transformers and PEFT frameworks. So the script at a high level, the script to be walked through is built to support dataset loading and tokenization, quantized model loading using bits and bytes, a 4-bit training, instruction tuning via custom prompt formatting, LoRa based fine tuning, QLoRA, evaluation and visualization of loss, and finally, model export, inference testing, and using in tools such as Llama Studio or POE. This video is not about getting too deep into some of these terms. So the information is given to you, and we hope that you will go out and get some readings about on this topic. Right? This is the use case that it will be based on. A pipeline designed for instruction base, as I mentioned, and this is the format, right? The format of the prompt. And this is aimed at fine-tuning the model to generate instructional, motivational, and task-specific response. Here is our main pipeline, the flow of what we'll be going through, and this is just part one of a series of videos to accomplish this. We'll load a data set, tokenize, configure, etc., just as I mentioned in the previous slide. And just a note, a Python function will be provided for generating and saving to your disk synthetic data set, and it will save it in the format of a JSON-L and also Hugging Face arrow. That is provided, and we'll go over that in this video, and that's where we'll wrap up this video. Okay, so let's dive into our let's dive into the code. All right, so I'm gonna give it this name here, that you see there. Just create my Python script. Okay. All right, so let's okay, so let's what I like to do, as I always did before, is I always like to add some notes to help you guys understand what it is that is happening. Much of this was covered inside of much of this was covered in the previous the slides a little while ago. So I'm just pretty much giving you the it inside of this script here. So I'll give you a moment to just peruse through that. It just talks about the use case that was just presented, and this script provides comprehensive pipeline, etc. There you go. And okay, so let's get some code in here. All right, we will need, we're gonna have another screen where we'll do compiling. Okay. All right, so let's start adding our dependencies. We'll import some dependencies. So I won't dive deep into each of these dependencies. What I would just recommend you to do is start looking at documentation of these. This is the Hugging Face Transformer package. It has several tools inside there that will help to tokenize and train models, organize training arguments, etc. In the slides, I talked about bits and bytes config. This is where we're going to be using it. So try to get, if you're not familiar with many of these, please, I would suggest that you reach out and try to get familiar with them. Okay, this config file here, it's just a config I created, and it has some variables that I don't want to open up on the screen because it exposes certain my keys for certain like OpenAI and so forth. So let me but I'll explain it to you real quick. Hold on a second. What I'm running on a small GPU system. It's a single GPU, so I'm just printing out some debug statements, and I'm assuming you'll go through your process of setting up your GPU if you're using GPU. If you're not using GPU, you can always modify this slightly to use a your local machine. It can be done. There's just quite a bit of work to do that. What I suggest to you, we'll be using class method style, just to highlight that. We're going to be using class method style, and when we get to the init function, I'll explain why I mentioned this. So we'll be using CLS instead of self. I like to use this method when I'm writing, and I like to write my my code in a object-oriented fashion, like so. I like to use classes. Anyway, this is the model we're going to be training. Okay, this is stored in Hugging Face. So I recommend for you to go out and get these set up. Okay, not all are necessary, but if you're going to follow our videos and we're going to be using, because we're going to be doing a lot of work with generative AI, artificial intelligence, etc., and they'll need these keys. So I have the GCP project keys, which is Google's cloud platform. It's optional because I'll be doing some cloud platforms stuff integrating with this. If you saw my other videos, I am on also doing videos on cloud engineering. You'll need Google these keys, especially this one and your Hugging Face. Those two is primary that you'll be using. These, if you don't have to get them right now, but if you're gonna get these, just go ahead and get them all. if you're going to be doing